Our last example here. Um, Spherical balloon expanding at the rate of 60 pi cubic inches per second. How fast is the surface area of the balloon expanding when the radius of the balloon is 4 inches? So this one's interesting because they're telling us the rate of change of the volume. I know that because it's in cubic inches per second. And they want to know the rate of change of the surface area. There isn't an equation that directly relates these two. So I think of this as like in geometry when you learned about circumference and area, you would get questions like if the radius is 5 inches, what's the area of the circle, right? So you use your area equals pi r squared. Then they'd ask you like if the radius is 4 centimeters, find the circumference, and you would use your circumference equals 2 pi r formula. Then they'd ask you if the area is, say, 36 square inches, find the circumference. So you'd have to first use your area formula to solve backwards, to find r. Once you have r, you then can use your circumference formula, plug r into that, and then solve for circumference. This is a similar idea here. So we have two things going on at the same time. We're going to have our area formula, our surface area formula, and we're going to have our volume formula for spheres. They want to know dA dt, so we've got to kind of end up there. We're going to start with the volume, and we're going to use the volume to find dr dt because we need to know what dr dt is. Once I have that, I can then go use that dr dt in this formula to solve for the area, the dA dt, the rate of change of the area. So the key is that I got to find that connecting piece, the rate of change of the radius. So let me erase this stuff as well. We're going to need some room. So we're going to take the derivative with respect to time. 4/3 pi is just the constant, so when the 3 comes down, I get 4 pi r squared and dr dt. We need dr dt. We know dv dt is 60 pi. When the radius is 4. So now I can solve dr dt. You can pause the video if you need to and see if you can get there. You're going to get about 15/16 inches per second. That's our dr dt. We can now use that over here when we take the derivative of this guy with respect to time. We now are looking for dA dt, but we know that the radius is going to be 4, and now we have dr dt is 15/16. So we can find the rate of change of the surface area. When you simplify all that out, you should get 30 pi square inches per second.